We also work with perfluorinated gases, and perfluorinated gases have a lot of important industrial applications. These include semiconductor processing. So for example, wafer etching or chamber cleaning in order to clean up after you've actually done the wafer processing. A lot of industrial processes will just flow a perfluorinated gas through. It will react with silicon or a semiconductor material that's left as residue and carry it away. Perfluorinated gases are also used in some metallurgical applications. For example, one gas that we work with, sulfur hexafluoride, is quite inert, and it's used as a blanketing gas to keep air away from a reactive molten metal during metallurgical processing. And so there are really not very many replacement gases because of their unique, or replacement chemistries because of the unique properties of these gases. But the challenge is, if they're just emitted to the environment, perfluorinated gases in particular have exceptionally long lifetimes in the environment. So there are not natural degradation pathways that are known. So the worst offender is sulfur hexafluoride, which ranks #1 in terms of what we call global warming potential. So this gas, if released on a per kilogram basis, has about 32,000 times higher global warming impact than CO2. Now, on a total volume or total scale basis, of course CO2 is the main offender, but we need to clean up these perfluorinated gases where we can, because every molecule that gets emitted is going to accumulate in the environment, and we're not going to be able to get them out. And what we've seen is a very sharp uptick in the concentration of perfluorinated gases in the Earth's atmosphere since we started to industrially use them. Currently, we do not regulate emission of these gases. To me, the opportunity is that they are typically used in fairly concentrated streams and emitted at what we call point sources. So I think they're really a prime target for technological approaches to capture and potentially convert at the source of use prior to their release into the environment.